We can kind of continue with these ideas and look at the rational zero theorem. So again, what does that mean? All factors, again, we're trying to find when the factors equal zero. And in general, what you do is you take your constant, which we sometimes call P, and then your coefficient of your highest degree is what we call Q. So really, the factors are going to be P divided by Q. So again, what's the factors of -6? Well, it'd be some sort of combination of positive or -1, 2, 3, or 6. And the only combinations to get 1 are positive or -1. So when we set this function equal to 0, our answer is going to be, again, anything divided by 1 is just itself. So our answer is going to either be 1, 2, 3, or 6, and then positive or negative, depending on what that looks like. So I'm going to go ahead and, again, write this equation out, set it equal to 0. X to the third plus 2x squared minus 5x minus 6 equals 0. And I always like to start with positive 1. Again, if you can't tell, again, 1 is very easy to sub in. And again, if we get it right away, awesome. 1 plus 2 minus 5 minus 6 looks like 3 minus 11. So I think we got to try a different number because that equals -8. That does not equal 0. So let's go ahead and we'll try, hey, let's try maybe 2. Since positive 1 didn't work, let's try positive 2. 2 to the third plus 2 times 2 squared minus 5 times 2 minus 6. 8, 4 plus 8 minus 10 minus 6. 16 minus 16. Hey, that looks a little bit better. That equals 0. So again, if x equals 2, my factor, again, because I need it to equal 0, is going to be x minus 2. So now that I've got something to work with, again, I can use synthetic division here. And I'm going to say, okay, just like I have been before, take this, and I need to take my coefficients from my original function, make sure we've got decreasing order, third power, second power, first power, so we're good there. 1, 2, -5, -6. I'm going to bring this first part down 2. That gives me 4. 8, which gives me 3, and 6 gives me 0, which is awesome. Okay, again, because I get a 0 here, I know that it's going to be a factor. So now I'm going to take those, let me see here. This should have been a 1 right here. This should be a 1. Now I'm going to take those numbers and plug them in. Again, my coefficient, whatever my highest degree, which was 3, I need to start 1 less. So I'm going to go 1x squared. So again, just x squared plus 4x plus 3. And then again, I also have to remember my x minus 2. Now I'm going to do my factoring work. What two numbers multiply together to get 3, but add to get positive 4? Well, the only way you can do that is with a positive 1 and a positive 3. So I could rewrite it as x plus 1, x plus 3, and then I still have x minus 2 on the outside. So again, what are our zeros? Again, because that was the whole thing, the rational zero theorem, our zeros are going to be x equals 1, or excuse me, x equals -1, x equals -3, x equals positive 2. Okay, another example, looking at the rational zero theorem. Again, try to determine, this time we've got the negative 20 is our, and again, our first coefficient, if there's nothing there, it's like a 1. So that's like 1 times negative 20. So I'm listing what are my factors. What are my factors? And again, 1 times negative 20 is basically just negative 20 divided by 1. So I've got positive or negative 1, positive or negative 2, positive or negative 4. These are all possibilities. And again, I like to start with positive 1 to see if that works first. And of course, the only positive or negative 1, anything divided by 1 is itself. So if we try 1, so again, I'm going to plug it in. 1 to the third plus 8 times 1 squared plus 11 times 1 minus 20. 1 plus 8 plus 11 minus 20. 9 plus 11 is 20. 20 minus 20 is 0. Woohoo! We are in good shape. So I could say that x equals 1 as a factor would apply. So again, that's what I'm going to use when I do synthetic, is I'm going to use a 1 here. Take my coefficients, 1, 8, 11, negative 20. All right, as I'm working through this problem, I bring down the 1. 1 times 1 is 1. This is 9. 9 is 20. And negative 20 plus 20 is 0. So that's awesome. Now I'm close to being done. I got to rewrite it. Again, this gives me x squared plus 9x plus 20. So my thought process is, again, what two numbers multiply to get 20 but add to get 9? That's going to be 4 and 5. So I could factor this as x plus 4, x plus 5. And then don't forget, we've got our initial one that we took out was x minus 1. So my factored form would be like this, and my zeros would be x equals 1, x equals negative 4, and x equals negative 5.
So what is ClickUp? ClickUp is an all-in-one production.
One last example, looking for the rational zeros theorem, and rational zero theorem. And so in this case, again, we want to find, okay, our factors, again, if this is P and this is Q, again, 6 times 1 is 6. So 6, or P over Q, what factors are possible? 6 over 1. And so again, I could do positive or negative 1, positive or negative 2, positive or negative 3, or positive or negative 6. And those are only going to be 1 as well. So as we look here, f of x equals, now I'm going to try 1. Again, I always like to pick 1. So if we plug in 1, again, does it equal 0? 1 to the third minus 11 times 1 plus 6. 1 minus 11 plus 6 does not equal 0. So let's try, I like to always try my positives before I get into the negatives. Let's try 2. Well, if I plug in a 2, minus 11 times 2 plus 6. 2 times 2 times 2. 8 minus 22 plus 6 does not equal 0 again. Okay, let's try 3 then. 3 to the third minus 11 times 3 plus 6. 3 times 3 times 3 is 27 minus 33 plus 6. Hey, that gives me 33 minus 33, which does in fact equal 0. So I know that, again, when x equals 3, and again, that's like the factor x minus 3. So we can keep moving. All right, now I'm going to use my substitution. So I'm going to say my synthetic division here, and I'm going to say my coefficients are 1. Don't forget, because we go from 3 to 1, we skip x squared there. So 1, 0, negative 11, and positive 6. Bringing down, I get a 1, 3, negative 2 times 6 is negative 3. So we get a 0. Awesome. So that's great. Now I'm going to go ahead and, again, reduce my x to the third by 1 and rewrite it. So I'm going to get x squared plus 3x minus 2. And now I'm thinking, all right, I know I've got this, and I've got my initial x minus 3 that I already calculated. And now I'm going to say, all right, can I get two numbers that multiply to get negative 2, but add to get 3? And I'm going to think, that's kind of hard because a negative times a negative is a positive. A positive times a negative. So I'm going to actually use the quadratic formula. So again, thinking about combining multiple ideas here, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A equals 1, B equals 3, and C equals negative 2. So as I go about plugging in this equation, okay, x equals negative 3 plus or minus the square root of b squared minus 4 times A times C all over 2 times 1. And now we need to start simplifying. So again, what do I get in the middle here? Negative 3 plus or minus 9 plus 8 all over 2. Negative 3 plus or minus the square root of 17 over 2. So I'm going to say that x equals negative 3 plus square root 17 over 2. And x equals negative 3 minus square root 17 over 2. So my final answer for my roots are negative 3 plus square root 17 over 2, negative 3 minus square root 17 over 2, and x minus 3. Those are my three answers. Okay, sort of our last idea in this is sort of a way to find out how many positive and negative real zeros we have. Now remember, the real numbers still mean it can be irrational, okay? But this is Descartes' rule of signs, and again, it kind of works like this. It tells us that the number of positive real zeros is equal to the number of sign changes. In your function, or minus an even number. So we'll focus on an even integer. We'll focus on this second part after that. I'll explain that in a bit. But for the first part, number of positive real zeros is equal to the number of sign changes in your function. So if I'm looking at my sign, okay, my first equation up here, I see that I start with a positive sign and then it goes to negative. So this right here is one sign change. Then I go from negative to negative. That's not a sign change, so I don't count it. And then I go from negative to positive. So right here, I have 2 sign changes. So I know that, again, as I go through finding these zeros, I know that this is going to be, it could potentially have 2 positive real zeros, or, again, or minus an even integer. Well, the smallest integer is 0. So I either have 2 zeros or I have 0. Okay, for positive real zeros. Now I'm going to look at the negative real zeros. So again, if I were to think about rewriting this, okay, now I need to take the negative of the function. So I'm going to rewrite it as every time I see an x, I got to put a negative in here. Okay. And then I'm going to say, okay, well, I still know that a negative number raised to an odd power is still going to be negative. So negative 3x to the third. An even number would cancel out. Negative times a negative is a positive, but I have a minus 4 out front, so that's still going to stay like that. And then a negative times a negative gives me a positive here, and then I still have plus 6. So now I'm going to go through and identify, all right, negative to negative, no, negative to positive, that's 1, and then positive to positive. So I have one negative real 0. And again, 1 minus 2 would be a negative number, so that doesn't make sense. So that's not applicable. So I either have 2 positive real zeros, 0 positive real zeros, but I know that I have at least 1 negative real 0 number.